everyone. The next lecture is on electrical components in a building. Now, in the last lecture, we studied how from power plants the electricity is generated and how it reaches our house. So, when this electricity is reaching our home, how it is being supplied throughout the building is the next part. And electrical components are those components which are critical in designing and executing any building. Our electrical service is a kind of service without which a building cannot function. So once we have received this electricity through our electrical poles inside our building, how will it transfer towards the end? So it's important for us to study all the components that are a part of it, which will finally lead us to the usage of electricity inside our building. It is important in terms of safety, in terms of user convenience, and in terms of aesthetic. So let's divide our electrical components in 4 types. Basically, the broader categories are divided into 4 types of devices. The first type is our input device. Then we have output devices. Then the third type is control and protection devices. And the last one is connectivity devices. Let's start with the input device. So input device is the device which is transferring your electricity from your distribution board towards your appliance. So that means the switches, the sensors, these are the ones which act as input devices, because when we switch on the switch, the electricity that we are receiving will be transferred to your appliance, right? So input device is something which is the connecting element of your electricity to your appliance. Then comes your output device. Now, output device is the last destination up till which the electricity reaches, and the last destination is your appliance. It can be your light fixtures, it can be your fans, and in appliances all the refrigerators, geysers, everything that requires this electricity to work is the output device, right? Then are your control and protection devices. These protection devices will help in eliminating overload of electricity or short circuit of electricity. So what can be these devices? These devices are like your fuses, your MCBs, your distribution boards, and then your circuit breakers. All these will come in control and protection devices. And the last one are the connectivity devices. These are the devices which will help in connecting your appliances together with the socket or the switch. So how can you connect your socket or switch? With the help of wires or maybe junction boxes, which will have the bulk of all the wires all connected together, then plugs that you have installed at the end of your appliance. So these are the devices which will connect your appliance to the socket or the switch so as to transfer electricity from the main source to your appliance or the last output device. So we'll start with electrical wires first. And electrical wires are basically the conductors which are allowing the electricity to pass through them, and they are carrying the current from your electrical pole to your building and then from your building to your appliances. Now, there are 2 terminologies. One is cable and the other one is wire. If I make this diagram, this can be your insulation which is in black color and there is a copper element inside it. So this is basically our wire, which is typically made up of copper and sometimes aluminium. And this outer body is made up of rubber or high quality polymer, which is a very strong non-conductor of electricity, and they are very thick so that no electricity passes through it. So this is your wire and this is the insulation. This whole element together is known as cable. But in normal conduct, when we are talking, we can call a wire also as a cable or a cable as a wire. But typically, traditionally, the innermost part is the wire and the whole complete thing with your insulation is known as our cable. So the materials with which a wire or a cable is made of, the internal part can be of copper or aluminium, and insulation, which is the outer part, it is generally of PVC or rubber, or there is one polymer which is called XLPE, cross-linked polyethylene. So this is a compound, a combination of different kinds of polymers which are stronger and highly insulative and with long life. So since copper is cheap and it is high in conductivity, that is why it is mostly used. But aluminium has more lifespan, it is more durable, but it is expensive. So it depends where we can use different type of material. Then we have two types of wires. First is the flexible wire. Second one is a single core wire. And third one is multi-core wire. Now single core wire is the wire which is the most simplest one, the one which has this outer coating and inner wire. The multi-core wire is the one in which you have a cable, but then inside this cable you have multiple wires of different colors. They are all wrapped around, and your flexible wire has the innermost copper layer like this. It is mostly used in small rice lights and Diwali or festive lights, and these are used commercially. Now, in the wires, there is a thing called color coding, and according to standards, we have three types of wires, which is the live wire, neutral wire, and the earth wire. Live wire is generally red, brown, or black. Neutral is always blue, and earth is always green or sometimes yellow. So these are the conductors which are used so as to transfer electricity. Now, second component are our switches. Now, what are switches? Switches are basically the device which can complete your circuit or can break your circuit. For example, if I have to light this bulb up and I have battery here, I have switch installed here. So if I close this, my circuit will be complete, and if I keep it open, my light will be off because the circuit is breaking. So switches are basically the devices which can be used to make or break the circuit, and the whole electricity depends on the switch. If you want the electricity to pass through the circuit and switch on any kind of appliance, then switches are the main component that will let it happen. Now we have different types of switches. The first one is single pole throw switch. Now this is the basic switch which you'll just switch on and switch off. Then we have two-way switches. Now, how does two-way switch work? Suppose we have a door and then we have steps, and on the ground floor we again have a door, but I need to switch on the light from somewhere. So I will have 2 meters installed so that I can switch this light on from this switchboard also and this switchboard also. So when I can switch on the same appliance with two different switches, that switch is called our two-way switch. Now the third type of switch is push button switch. Push button switch, like the name says, it is somewhere circular or maybe rectangular. This is a single button. It does not have off. It only has the on button. When you press this thing, button will switch on. So this is basically used at the time of emergencies, like in our alarms or for our bells. So that function only needs a single push things so as to switch it on. The next type of switch which we use nowadays is known as modular switch. It is only the only thing is it is modernistic, it is sleek, and you don't see the switches inside your frame. They are just built like this, and you don't see anything which is embedded or embossed. They just go with your design, and for aesthetic purpose it is used these days. So the only thing about it is sleek and modern, and yeah, it's just about the aesthetics. Your third type of component is our socket. Now, socket is basically our outlet, which is allowing the electrical devices to the power supply. So, socket is something like this. These are the connection points that provide electricity. These are the connection points that is providing your electricity to various appliances or devices. Now, there are four types of sockets. First is our 5 ampere socket. Now, as the name suggests, this socket only allows 5 ampere of current to pass through it, and this is a light load socket which can only carry light loads like fans, lights, table lamps, chargers, everything that does not need high amount of electricity or voltage. It is put up in your 5 ampere socket. And the next is our 15 ampere socket. Now this will carry more heavy loads. So the appliances like refrigerators or geysers or maybe microwaves, anything that requires more heavy amount of loads or more voltage will be put in our 15 ampere socket. You might have noticed sometime what happens in the small socket which is of 5 ampere when we put a multi plug or an extension and we start using something very heavy appliance on this, then these socket will start melting and your plug which is put inside this socket will get heated up. Why does this happen? Because this socket is meant to take the load which is only for 5 ampere, but we are overloading it with more than 5 amperes of current, which will ultimately lead to more release of heat. With this heat, these holes and sockets and plug, everything will get heated up and they can melt. So it is never advisable to use a 5 ampere socket for heavy load of appliance. The third type of socket is our universal socket. Now, what is a universal socket? It is a socket that can be used universally or globally everywhere. And in one socket, you'll find you can have both 5 ampere plug and 15 ampere plug. And even the shape matters. The hole is something like this and this and this. So it can take a round plug also and a straight line plug also. So universal sockets supports international plugs. Then is without switches. The sockets without switches. These are the sockets which are installed permanently in the kitchen, for example, behind your microwave or OTG, which do not require switching on and off the appliance regularly. You can just fix it permanently, and when you want to use the appliance, you can just directly switch on it from the button that is on your gadget. So you don't have a switch attached to it. Coming to the next, fixtures. Now, as the name suggests, fixtures are something which are fixed. The fixtures refer to something which is permanently installed in your home, and it is specially for your lights and ventilation, mechanical ventilation. So all the lighting fixtures like lamps, like bulbs and tubes, everything comes in a fixture, and AC also comes in a fixture, which is our mechanical ventilation. In our lights, we have different types of lighting fixtures. We will study them in detail later on, but just for your knowledge, we'll discuss them. First is your ceiling mounted fixture. Anything which is on your ceiling, any light which is on your ceiling is your ceiling mounted fixture, any bulb, lights and tubes. Then we have wall mounted fixtures. which are on your wall. This can be CCTV's camera or exhaust fans or any other type of bulb. Then we have false ceiling lights, which are again on your ceiling. And we also have pendant lights, which are just hanging like this from your top, looks like a pendant. So we have different kinds of lighting fixtures that come in these example. Other things like geysers and chandeliers, they also come in fixture, because chandelier is a type of light, and this is again an appliance used for warming up your water. Now the next main component is our distribution board. This is something that we could have discussed at first, but let's do it now. Now, when the electricity is coming inside our house, you might have seen there is a very big panel or a kind of box that is holding up small meters inside it, and it has a main switch which is of red color. When you switch it on, the electricity of the whole building can switch on, and if you switch it off, the whole electricity of the house can go off. So distribution board is basically the electrical control unit of the house, which is consisting all kinds of MCBs. And the full form of MCB is miniature circuit board. So as the name says, it is a small mini circuit board which is having small fuses inside it, and every MCB is attached to an appliance or a socket or a fixture. And if any fixture or any socket gets overloaded, this MCB, which is in T shape, it fuses and it goes down like this. So you might have seen that when the electricity goes down, you just pull it up and the electricity comes back. So MCB is basically an automatic electrical switch that turns off when there is overload or short circuit in your house. So we can have different distribution boards on different floors as well. And yeah, so your distribution board has your main switch, your MCB, and there is one unit call which is RCCB. It is residual current circuit breaker. Now what is the MCB doing? In the MCB, it is protecting us from overload and short circuit. And when there is the leakage of current inside our building, it is the responsibility of RCCB to just cut off the power and send the extra leaking electricity to the earth. So these both have different purposes, and if the type of failure is related to short circuit or overload, MCB will function, and if it is about the leakage of electric current, then RCCB will come in use. Now the next thing is our electrical meters. Now electrical meter, everyone has these meters installed in their houses, which is kept for measuring the amount of energy consumption in our house. So this is the measuring instrument or a device used to calculate the total amount of electricity consumed by a building. So there are different types of electrical meters. The first one is analog meter. So everyone knows what is an analog watch. Analog watch is something which changes the time and date automatically. Just like an analog watch, at the olden times we used to have analog meters which were not digital, but they used to change its state on that circular motion, like in the way the analog watch works. Then next is the digital meter. Now, as it says, in digital meter, we get digital value of the energy consumption. We used to have this 888 kind of a pattern, and if the value was 2, it would look like this, and if the value was 3, it would look like this. If the value was 4, it would look like this in the 8 dashed area. So this was a digital one. And now comes our smart meters, which will tell you every data, how many units, how much is your electricity bill, all the dates. So it is kind of a remote reading and tracking device. Everything can be kept inside, every information can be kept inside this smart meter. And the last are your fuses. Fuses are basically the safety devices that melts down when there is overload or there is short circuit in your home. So these will melt away, and after melting, the circuit inside your building will break, and when the circuit breaks, there will be no electricity in your home. So when the flaw inside your house will be repaired, then you can change this fuse again so as to start the whole electricity inside your building. So we have different kinds of fuses. We'll again discuss them in detail in the next lecture, but there are 3 to 4 types of fuses. That other than that, we can have other components in the residential wiring which can help us in keeping the building safe from any kind of failure. For example, earthing system. This will be our next lecture. The junction boxes, what is conduits. So every kind of failure that we have in a building will be discussed in the next lecture. This was all about the electrical components inside a building: our meter, distribution board, fixtures and appliances, sockets, switches, and electrical wires. Yeah, so these were the 4 types of electrical components in the building. Thank you so much. See you in the next lecture.